let f be the function given by f of x equals 300x minus x cubed. On which of the following intervals is the function f increasing? So we're given this function f, and what we need to do is find out which intervals the function is increasing. Meaning we need to find the intervals where the derivative, the first derivative of f of x, so f prime of x, is greater than 0, meaning it's a positive number. Because the intervals where f is increasing is equivalent to the intervals where the derivative of f is greater than 0. So let's find the derivative of f. We can just use simple power rule. So the derivative of 300x, so x has a first power here. So we multiply 300 with 1, we're left with 300, and subtract 1 from the exponent. So 1 minus 1 is just 0, and x raised to the 0th power is just equal to 1. So 300 times 1 is just 300. And then we do the same for x cubed. Multiply by 3 the exponent, and then we subtract 1 from the power, so 3 minus 2 is 1. So this is the derivative of f of x. And now we need to find out the critical points of f of x. So the critical points happen where the derivative is equal to 0. So we need to find out where f of x equals 0. So we'll set the derivative equal to 0 and solve for x. So let's move the negative 3x squared to the other side. So we'll have 300 equals 3x squared. And then we can divide both sides by 3 to get 100 equals x squared. And then if we take the square root of both sides, we'll get x equals plus or minus 10. So that means our critical points happen when x equals 10 and x equals negative 10. So now let's draw a number line and label our critical points. We have one critical point at x equals 10 and another at x equals negative 10. Now, these are our intervals where we can determine whether f is increasing or decreasing. Because at critical points are the only points where f, the graph of a function, can change whether it's increasing or decreasing. So we just need to find out what is the sign of f of x in these intervals to see whether it's increasing or decreasing. So let's start at the left of negative 10, from negative infinity to negative 10. Let's plug in something like negative 11. So if we plug in negative 11 into here, let's actually factor out this 100 minus x squared. So I just factored out a 3 from the first derivative here, just to make our calculations a bit easier. So if x equals negative 11, we know that 11 squared is 121. So we'll have 100 minus 121, and we know this is going to give us a negative number. So that means for values of x between negative infinity all the way over here until negative 10, the value of the first derivative is negative. So that means in this interval, the f of x is decreasing. It's decreasing. Now let's check values between 0 and 10. If we plug in, say, negative 5 for x squared, we'll have 100 minus 5 squared, which is just 25. The negative cancels out because a negative number squared just gives us a positive one. And we know that 100 minus 25, that's just 75. And if you multiply that by 3, we're still going to get a positive number. So that means in this interval, the derivative of f is positive, which means that in this interval, f of x is increasing from negative 10 to 0. Now let's plug in something between 0 and 10. If we plug in 5 again, we'll just have 100 minus 5 squared, which is 25. And if you multiply that by 3, we're still going to get a positive number. So from 0 to 10, we're also increasing. Now let's plug in something between 10 and positive infinity. Let's do 11. So 11 squared is 121, and 100 minus 121, that's going to give us a negative number. And when we multiply that by 3, it's still going to be a negative number. So that means that since the derivative of f of x is negative from 10 to infinity, positive infinity, that means our f of x is decreasing in this interval. So it doesn't matter which number we choose between the intervals, as long as they are in the separate intervals, the sign of any number in this interval will match what and will all be the same. So it doesn't matter if we're in the interval between 0 and negative 10, whether we choose negative 1 or negative 9. It'll always give us a positive number for f prime of x, because we already calculated that negative 5 gave us a positive number. That's why we calculated these critical points, these 3 critical points here, because it is only at the critical points can f of x change whether it's increasing or decreasing, meaning the sign of f prime x can only change at the critical points, where f of x equals 0, which we calculated right here. So from this number line, we found that from negative 10 to 0 and from 0 to 10, the sign of f prime of x, the first derivative, is positive, which means that from negative 10 to 10 is our interval where f of x is increasing. So B is the correct answer.